Welcome back to the channel. I'm going to demonstrate how to create a brand new neural network to recognize a number of classes, and the whole thing will take less than 30 minutes. Here's the final output, where the network detects defects in leather. These images are from the MV-Tech anomaly detection dataset. I will link to it in the video description. Prior to starting, I told myself I'd show the version numbers of the software I'm using, but I forgot to do that. I'll insert a screenshot here at the start so people know what I'm running on both my Ubuntu VM and training rig. First thing I do is copy the images from the dataset to the local directory in my VM. I grab all the images and copy them into my neural network leather directory. Note the time. It is 16:08 or 4:08 p.m. We'll check the time again at the end of the video when training is finished. I need to create a names file needed for Darknet. This file needs one line for every class of object to detect. Using Darkmark, I will then annotate only 10 images of each class. I'm limiting it to 10 to show what can be done in a half an hour with a very small set of images. First thing I'll do to annotate is to press F to bring up the filter window and create a filter for all the images located in the folder named color. Then I press R to randomize the images. Next, I annotate exactly 10 images from the color folder. I repeat this process 4 more times for cut, fold, glue, and poke. Once I have 10 images from each category annotated, the last portion to annotate are the negative samples, which for this network are images of leather that don't contain any defects. The letter N is used as a shortcut key in Darkmark to indicate there are no objects of interest in the current image. This way, I can quickly annotate a large number of images. Once the images I need are annotated, I remove all filters. Right mouse click, select the Flip Images option, as well as the Rotate Images option. Since these images have a square aspect ratio and none of the classes have a concept of left, right, top, or bottom, this allows me to easily augment the number of images and annotations used to train. Take a peek at the statistics. This gives me some information on the annotations so I can decide what network dimensions to use. I have another video that describes how to select the optimum network dimensions. I'll include a link to that video in the description. Right mouse click again and select the option to create the Darknet files. I decided to use 416 by 416 for this network. If this was a real project and not just a quick demo, I would have gone through the math to pick the optimal network dimensions. Using 4000 for max batches is a bit risky since I have 5 classes I want to detect. But the images are very repetitive and I only annotated 10 images of each class, so I kept it at 4K. Normally for a 5-class project, I probably should have gone with 10K, but at the same time I was hoping to keep the project under 30 minutes. The next few options are very important. I have other YouTube videos where I discuss this window. I definitely want to resize the images. Unless you're using Darknet YOLO to find text fields, the random crop and zoom is probably also a good choice for most projects. You do want to limit the negative samples, and you want to train with all images. If you're surprised, please see the Darknet YOLO FAQ where this is explained. You do not want to use the Limit Validation Images option. That was added as a workaround to a specific issue, but it will negatively impact your network, so keep it off unless absolutely necessary. In the next sections, I make sure the YOLO anchors are recalculated, and because there isn't a lot of variation in the color of the leather, I turn down the 3 color options. At this point, I'm ready to generate the Darknet YOLO files. Note how Darkmark not only generates all of the necessary Darknet YOLO output files, but it also generates a training script to make things as simple as possible. Next, we quit from Darkmark with the escape key and use the send file script Darkmark wrote to send all of the images, annotations, and training configuration from the VM where this is running to my GPU training rig. Once the files have copied over to the GPU training rig, we run the script created by Darkmark to complete the training. As you can see, it will take approximately 10 minutes to train the neural network. That's not a mistake. It really will take just 10 minutes to fully train a network from scratch. During training, I peek at the chart.png file to see how training is progressing. You can see the first mean average precision calculations happening once we reach batch 1000. From there, the results quickly get better. Note the time here when training has finished, 16:33. We copied the files to the VM and started Darkmark for the first time at 16:08, just 25 minutes ago. So we copy the weights back to the VM, where I do most of my work, and from this VM, we can run dark help to see what the network outputs. Remember that we only annotated 10 images per class, and we only trained with max batches equal 4,000, so the results won't be perfect. But we can see promising results, and from here it is trivial to annotate more images and retrain using our existing weights until the network performs as we need. I'll also bring up Darkmark again. You can see how Darkmark loads the configuration and the weights, and then shows us predictions on images that have not yet been annotated. With the A key in Darkmark, you can accept the predictions, which lets you quickly improve your neural networks. There you have it, a neural network project annotated and trained in less than 30 minutes. As usual, please see the video description for relevant links. I'll also include a link to the Darknet YOLO Discord server if you need any help. Thanks.